We are now going to look at compounds and writing equations and doing some calculations on compounds. First thing is on the elements. We have a set of elements that are diatomic. That means under normal conditions we find these elements containing two atoms, molecules of two atoms. And because this is how we find them, we want to write these that way in compounds, in chemical equations. So we need to know the diatomic element, so every time we write it in a chemical equation, we're going to be writing it correctly. This will allow us to balance the equation correctly. So those elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. A way of remembering it in mnemonic is have no fear of ice cold beer. So have is hydrogen, no is nitrogen, fear is fluorine, of is oxygen, ice is iodine, cold is chlorine, beer is bromine. So these these elements are diatomic. So air consists about 80% nitrogen, it's N2, and 20% oxygen, O2. There can be other forms of these elements. Oxygen, O2 is a stable form of oxygen, but if you run an electrical current through it, we can create O3, ozone. Ozone is more reactive. Ozone reacts relatively fast with organic compounds to oxidize them, and after ozone reacts with something, it becomes O2 again. So there can be other forms, but these diatomic forms are the forms that we find. Hydrogen we always find is H2, nitrogen is N2, fluorine is F2, iodine I2, chlorine Cl2, bromine Br2. This is how we see the elements. These elements in compounds can have other subscripts, but by themselves they're going to have a subscript 2. Now we're going to learn some names of compounds. We're going to learn how to write formulas and names of simple compounds. We're going to be learning a naming system. There are going to be some names that do not follow this system. The most common ones would be H2O, water. It would follow the naming convention of dihydrogen oxide or dishydrogen oxide, but we're just going to call it water. Ammonia, NH3, following our naming conventions, would be nitrogen trihydride. We're not going to call it that, we're just going to call it ammonia. There are other common names that are used on commercial products. We're not going to worry too much about those common names, and we're not going to get into complex names either. So in compounds, we're going to write formulas of compounds. We're going to write molecular formulas of compounds. Molecular formula of compounds represents a compound as is found in nature. So in a formula we're going to have the symbol for the element and a subscript showing how many atoms of that element are present in that compound. So the molecular formula shows the compound as is found in nature. Often on the way to the molecular formula we have to go through the empirical formula. The empirical formula is the lowest whole number ratio of atoms in a compound. The empirical formula can be equal to the molecular formula, or the molecular formula is going to be a whole number multiplier of the empirical formula. We can categorize our compounds in a couple different ways. So covalent compounds, which could also be called molecular compounds, are compounds containing nonmetals with nonmetals. Nonmetals bonded with nonmetals are covalent compounds. Compounds can also be categorized as being organic or inorganic. Organic compounds are compounds containing carbon. Inorganic compounds do not contain carbon. And there's ionic compounds that will contain a form of carbon that will also be called inorganic. So in our example here, water has no carbon, so it's an inorganic compound. Methane, CH4, has carbon, so it's organic. Ammonia has no carbon, so it's inorganic. Ethanol has carbon, so it's organic. These are all molecular compounds, all covalent compounds, because there's no metals present, just nonmetals.